Hello, dear friends, my dear students. I am here, Lalit Kumar P. Bhaiya, Associate Professor, Electronics and Telecommunication Engineering Department, Bharati College of Engineering and Technology, Durg. Dear students, in last video, that is in video number 46 of 30th September, we have seen measurement of velocity. The sum of the instruments for the measurement of velocity we have seen. Today we will go for the other instruments of the measurement of velocity, and then we will go for the methods for the measurement of displacement also. This is part of your syllabus. What we have seen yesterday, we will review it and continue for the next. This we have seen generalized measurement system. This measurement system with calibration and parameter analysis, and which parameters is in your syllabus for the measurement that we have seen. Next, we have gone through the velocity measurement. This is LVT, linear velocity transducer, we have seen for measuring linear velocity. This is the differential coil is used here, two coils for getting the differential measurement, velocity measurement. Then we have discussed this. What is velocity? Velocity is the first derivative of the displacement, and linear velocity is defined as the rate of change of the position vector with time at an instant in time, that we have seen. And these are the various methods used for the measurement of linear velocities utilized. We have seen out of this electromagnetic transducers, in which we have gone through the moving magnet type and moving coil type. Also we have seen seismic transducers for the measurement of velocity. Then we have seen linear velocity transducers. Now we will go for the digital transducers. Let us see this. We have seen the moving magnet type and moving coil type. Moving magnet type transducer, this diagram, and how the permanent magnet which is kept between these two coils, and the voltage is proportional to the velocity, that we have seen. And this equation for the output voltage E0 is equal to B into A into N into V, where E0 is equal to K into V, proportional to velocity. This we have seen. Advantages and disadvantages of this method. Then moving coil type velocity transducer. This transducer we have seen the movement of the arm is produces the velocity, and that is measured through this coil which is kept between poles south and north, that we have seen. Their advantages and disadvantages we have seen. Then this seismic type velocity transducer, we have discussed about this. This is the diagram for this seismic type velocity transducer. This we have discussed. And then we have seen LVT. Initially also we have seen this LVT, linear velocity transducer, with this coil 1 and coil 2, and we will get the DC output voltage V0 with the movement of the core inside the coil. So movement of the core is produces or change in velocity, and that will be proportional to the differential voltage across this coil. This we have seen. the core slides inside the hollow cylinder tube called a bobbin, and a DC voltage is generated when the core moves. This principle we have seen. Since the two coils are wrapped with opposite polarity, and since the magnet also has two poles, north and south, the south pole induces the voltage primarily in coil 1 and the north pole induces the voltage at coil 2. It turns out that the net voltage is proportional to the speed of the core. That means it is velocity. And this type of LVTs are used in milling machines that we have seen. Now we want to go for the digital transducers. Some digital transducers are used for the measurement of velocity as well as the displacement. Velocity is the rate of change of displacement with respect to time that we have seen, and you know very well it. If a number of evenly spaced marks are placed on the moving object and the number of these marks is n passing at a given time t seconds, the velocity is v is equal to n into d by t, where d is the distance between the marks between the two objects. The marks can be made photoelectrically, or there may be a protrusions which are detected by inductive or capacitive techniques. So in digital transducers, what we do, we use the photo detectors, and through the windows on the mark, the light will be fallen and that will be marked, and movement of the core will be the movement of these marks, and if n number of marks are there, then velocity of the core movement v is equal to n into d by t, where d is the distance and t is the time distance between the mark. So this type of digital transducers are available. The fifth one used for this measurement is the transducer using Doppler effect. You might have heard what is Doppler effect. The Doppler effect is an effective and accurate method of measuring linear velocity. If a narrow radio beam or ultrasonic beam is aimed at an object, the beam will be reflected back to the source. However, if the object is moving, the frequency of the signals received back differs from that of the transmitted signal. So what will happen in this Doppler effect principle? The ultrasonic beam will be fall on the object particular, and that object may be moving object. So it will be reflected back to the source, and that reflection will be different from the original one. You can see here radar Doppler velocity meter. This is the moving object, and this is the radar emitter and detector. This is the transmitted wave to the object, and this is the reflected wave. This is the reflected wave. So reflected wave has a phase difference between the original wave, and this object will be continuous moving. Radio waves of wavelength lambda are transmitted, that is called as incident wave, towards the moving object. The object moves with velocity v at an angle theta relative to the radar unit as sketched. You can see this diagram. Then, just a minute please, it is disturbed here. Then the radio waves reflect off the moving object and are sensed by a radio wave detector receiver that is also mounted on the radar unit. The detector measures the frequency of the reflected radar beam, and the unit compares the frequency of the transmitted and reflected beams. Frequency will be compared by both the transmitted and reflected beams. Doppler radar units are used by police to measure the speed of the automobiles, and they are also used in professional sports to measure the speed of the baseballs, etc. These are the applications. Laser light can be used in place of the radio waves. Then the device is called as laser Doppler velocity meter. Laser Doppler velocity meter. So this diagram you can have easily understand. This is the transmitted beam. This is the reflected beam. Here is a detector. This is emitter and detector is there. So frequency of this transmitted and frequency of this reflected wave will be different, and that will be marked as the speed of this or velocity of the object. Then number 6 is velocity measurement using displacement and acceleration sensors. Displacement sensors, velocity is the time derivative of the displacement, you know, dx by dt. We could calculate velocity by taking the time derivative of displacement measurement from a displacement sensor like potentiometers, LVDT, laser displacement meter, etc. This technique is often used for measuring the velocity of very fast moving objects like bullets. Disadvantage: the process of differentiation of a signal amplifiers the noise in the system. Acceleration sensors, velocity is the time integral of acceleration. Here another relation is used, that is V is proportional to integration of the acceleration. Equation is V of t is equal to V naught plus integration of A of t into dt, where V naught is the initial constant and A of t is the acceleration, changes with respect to time. Unlike the differentiation, the process of integration decreases the noise in the system. Thus, velocity measurement by integration of acceleration data is generally a wise choice. Here it is not much necessary to go for the measurement of angular velocity, but as far as your knowledge, you must also know this measurement of angular velocity. As per our theory, we will concern with the linear velocity only, but time being, you must also know about this, something about the angular velocity, measurement of the angular velocity. The measurement of angular velocity may be made with a tachometer. The tachometer may be defined as an instrument used for measure of angular velocity as of shaft, either by registering the total number of revolutions during the period of contact, or by indicating directly the number of revolutions per minute. An instrument which either continuously indicates the value of rotary speed are continuously displays the reading of average speed over rapidly operated short interval of time. So angular velocity means to measure the speed of a rotating shaft like motors, generators, like this. The tachometers are classified as, and tachometer is the well-known instrument for measuring the speed. Measuring the speed means measuring the velocity of the angular movement, angular speed, called as the angular velocity here. Mechanical tachometers and electrical tachometers. This is the mechanical tachometer which we use in the laboratory also for the measurement of the speed of the motors. Shaft is there, spindle, and starting and reset button is there, and dial. This is the dial which will give the RPM, and here starting and reset button is there, and this is the spindle. This is connected to the shaft, and you can measure. This is the hand speed tachometers, and it can be used for the measurement of the speed from 20,000 to 30,000 RPM with a 1% accuracy. It has a certain disadvantages of this mechanical tachometers. Impose a load on the shafts, and account of inertia also is there. And the mechanical tachometers normally use the arrangements wherein a counter is used for counting the number of events. So these are some disadvantages of mechanical tachometer. You can go through it. Then electrical tachometers, called as the DC tachometer generators. DC tachometer generators. You can see here diagram. This is the speed to be measured here. This is north pole, this is south pole, and these are the brushes. These two are the brushes, and this is resistance, and this is PMMC voltmeter. This is motors commutator, and this is permanent magnet. So you can measure this speed in terms of this voltage or in terms of this RPM. This electrical tachometers can also be used. It has certain advantages and disadvantages. You can go through it, please. So this is the measurement of the angular velocity by mechanical tachometers and electrical tachometers, right? Then you have in your syllabus the measurement of the displacement also. Potentiometers are very common devices used to measure the displacement. Linear potentiometers is used for linear measurements, and an angular potentiometers are used for angular measurements. The linear potentiometer is a device in which the resistance varies as a function of the position of the slider. You can see this is the potentiometer, linear potentiometer, and this is a slider here. So when this slider moves, the resistance will change, and as the resistance changes, according to output voltage will change. So movement of this slider is the will be connected or will be treated as a displacement, and this displacement is converted into this voltage. And this is the angular rheostat potentiometer, like this. So here this is a slider, this will change like this, and angular movement will be observed as a change in voltage due to change in resistance. So this is for the angular movement, angular displacement, and this is for the linear displacement. These potentiometers can be used. This is the linear displacement. Linear potentiometers are used. You can see here some drawbacks, issues are there: noise, linearity, resolution, measurement range, lifetime discrete steps. So this is the potentiometer, and here this meter is shown here. Potentiometer for volume control supposed to be, and this is the equation. V naught is equal to theta by theta max into Vi. V naught is the output and theta you can say is a displacement, and this is a maximum displacement, or this can be written as this is for angular movement and this is for linear movement. X is the displacement, L is the total displacement, total length into Vi. So this is the measurement of the display. Angular potentiometers can measure the angular displacement in multiple rotations. Angular potentiometers are used in common devices such as radios and television as a volume and tone controls. These are normally used and you are using daily as a knob of radios and television for the volume control. These potentiometers are used. Potentiometers do have limitations. Because of sliding contact, they are subject to a wear. Furthermore, the output tends to be somewhat electrically noisy since the slider resistor contact point has some resistance, and this can affect the output in the somewhat random manner. This effect often becomes worse with the age of the devices due to contamination of the contact surface. The wire-wound potentiometers display output as the slider contacts successive turns of the wire winding, and conductive plastic potentiometers were developed to eliminate this stepwise output and now widely used in mechatronic systems. So this way you can measure the displacement and you can have the measurement of the velocity. So dear friends, students, kindly go through the details of the measurement of the velocity and measurement of the displacement. These two videos are prepared and it is posted on your classroom also. If you have any difficulty, you can ask me at any time, please. And if you require a notes on this, or if you require this PPT, you can ask me. You will get it. Thank you very much for listening this video. Last video and this video, these two videos will cover the measurement of velocity and measurement of displacement according to your syllabus. The question is that describe one of the method for the measurement of velocity, linear velocity, or describe the method for the measurement of the displacement. How the angular displacement and linear displacement can be measured. How the angular velocity and linear velocity can be measured. These questions may be asked. What are the different methods for the measurement of the velocity that you have to explain? I have told you in this video 6 methods, out of which if asked you can explain one method. So this is all about measurement of velocity and measurement of displacement here. I think more than 95%, about 96% syllabus I have covered till now. Only the remaining part is tacho generators and digital part. 4 to 5% part is remaining that we will see in the next videos. Thanks a lot for listening. Thank you very much.